In this video, we're going to be looking at box plots. In the previous video, we learned about quartiles and different measures of position and how to identify outliers. We're going to use this information to start building box plots or box and whisker plots. The 5-number summary for a data set consists of the lowest data value, or minimum, Q1, Q2, Q3, and the highest data value. Find the 5-number summary of the following data set by hand. Label your values appropriately. So this is indicating to do this by hand. So we want to make sure that we sort our data, put it in order from least to greatest, but we want to use the techniques that we saw in our previous video rather than Excel to find, in particular, Q1 and Q3. With that said, even though we're not going to be using Excel to find Q1 and Q3, you could use Excel to sort your data. So go ahead and pause the video now, and this will give you an opportunity to practice entering data and sorting it, and then record that data sorted, and we'll continue on with the video. So here we have our data listed in order. We do have an even number of data points. So let's identify Q2 by looking at the average of our two middle terms. Here are the two middle terms. And since they are the same, we know that our second quartile, our median, is going to be the same. To find Q1, we're looking at the median of those data values for that lower 50%. In this case, that's an odd number, so Q1 is going to be 39. Similarly, to find Q3, we're going to look at those data values that are above our median, or that top 50%. And that is an odd number, so Q1 or Q3, excuse me, is going to be that middle value of 40. So putting this all together for our 5-number summary, our minimum data value is going to be 38. Q1 is 39. Q2 is 40. Q3 is also 40. And our maximum data value is 43. A box and whisker plot, or a box plot, is a graphical representation of that 5-number summary. If a data set has outliers, outliers are indicated by a point, an X, or an asterisk, depending on what software you're using. Here's an example of a box and whisker plot without an outlier constructed in Excel. So this bottom line represents our minimum. The first part of this box represents Q1, Q2, Q3, and our maximum. So we have our minimum here, Q1 here, Q2 here, Q3 here, and our max. And Excel also shows the relationship between our median and our mean. Here's our mean right here, indicated by a little X in the middle of that box. Here are some examples of box and whisker plots with outliers. So in this particular software, outliers are indicated by those little open circles. So depending on the software, like I said, the outliers might be represented differently, but they're pretty obvious because they do fall outside of those whiskers. Now, in both of these examples, we've set up vertical box and whisker plots. We can set them up horizontally. If it's set up vertically, we read from bottom to top, or min to max. It's never min to max going down. And then if they're set up horizontally, we would read it from left to right, going from least to greatest. So looking at this first box plot, our minimum is here, Q1 is here, Q2 is here, Q3 is here, and our max is up here. that outlier is still a data point and it's our highest data point. So what is this point right here? There is a significance to where we draw our whiskers. They're not arbitrary. So this particular point is the largest data value that's less than our upper fence. So it's the largest data point that's still inside of our fences. Now this second box plot illustrates a box and whisker plot without any outliers. So we still have our min, Q1, Q2, Q3, and our max. So our whiskers extend to our minimum and maximum values. And in this last box plot, starting from the bottom, that outlier is now our minimum. Q1, Q2, and Q3 are always the values used for our box. And this is our max. And now this lower whisker, the bottom whisker, where does it go to? It extends to the smallest data point that is greater than our lower fence. So it's that smallest data point that's still inside of our fences. Make a box and whisker plot for our data on gestational age. We're going to assume that there are no outliers in this example, but you could test your low and high by finding your fences. So typically if we have any outliers, they're going to be our lowest data value or our highest data value. We might have some additional, but that would be a one way to test. But we're going to assume for this construction that we have no outliers. So we're going to set up a horizontal box plot here. And we're going to start by scaling our number line. Because our data doesn't have a very large range from 36 to 42, we're going to scale it a little bit more spread out. So we're going to go 36, 37, 38, 39 through 42. Now I like to start by setting up the box because it is set up using Q1, Q2, Q3. So Q1 is 38, so that's going to be the left side of my box. Q3 is 40, which gives me the outside of my box. So there's my box, and inside of that, we're going to mark Q2 at 39. Now our left whisker, or our lower whisker, is going to extend to the minimum since we're assuming no outliers. That would go to 36. And you can choose to close that off or not. It doesn't make any difference. That's a personal preference. And then our right whisker, our upper whisker, is going to go to our max data point, or 42. Now, looking at this, what could we say about the shape of this distribution? Well, it's important to realize that the shape is showing, or this box and whisker is showing the quartiles. So this is 25% of our data between here and here. This is 25% of our data. This is 25% of our data. And this is 25% of our data. This also looks pretty symmetrical on either side of Q2. Because it's symmetrical, we would say that this has a normal distribution. Use the following data to make a box and whisker plot, including any outliers. So we're going to set this up. We're going to find our 5-number summary, both by hand and using Excel. Either way, we want to start by putting our data into Excel and sorting it. So go ahead, and if you open up your Excel file We do have a tab for that. So looking at Excel, this tab 2.06 box and whisker, here's that data set that we have. The first thing I want to have you do is sort your data in order from least to greatest. We're going to want to have this done for our finding our quartiles by hand. If you're using Excel, you don't need to have the data sorted. It will automatically figure that out. But since we do want to do this by hand and using Excel, we want to sort the data first. So we do have an even number of data points. So that means these two data points are the middle data points. So I'm keeping track on my notes as well, how we're finding Q1, Q2, Q3 by hand. So we can see that our minimum data point is going to be 42. And our maximum data point is going to be 69. Q2 is going to be the average of those two middle points. So it's the average of 54 and 55, which is going to be 54.5. Which means then that the median of these highlighted data points or selected data points gives us the value of Q2 or Q1. So here's that lower 50% of data. Here's the upper 50% of data. So to find Q1, we want the median of this yellow highlighted data. Since it is an even number of data points, we're going to use the average of our two middle points. So it looks like Q1 is going to be 50.5. And then for Q3, we're going to use the average of the two middle points of these blue data points. So those two middle values look like 57 and 58. So Q3 is going to be 57.5. Now, if I undo all of this, just to get back to that original data set, I'm just going to show you that we don't need to have the data sorted in order to use Excel to calculate quartiles. So there's our original data set. I'm going to add some labels here. So I'm going to insert a column so that I can do min, Q1, Q2, Q3, and max. So I'm setting up labels for that 5-number summary. And we're going to look at the functions that we use to find these. Now, we haven't talked about calculating minimum, so let's just do some trial here, some trial and error. We know that in Excel, we want to start functions with an equal sign. So what do we think the name of the function would be if we're trying to find the minimum? Well, let's start typing minimum. Oh. And the function min returns the smallest number in a data set. So we can find our min using that function and select our data. And there's our minimum of 42. Now, because we can sort data, this really isn't necessary to use that function. But if we had a really, really large data set, it's very handy if you can just select a bunch of data and say, tell me which is the minimum of this. For Q1, we're using that function, quartile. Now, if you notice, there's two different quartile functions. We want to use the quartile.exe. So we're going to double click that or type it in, and it shows that they want the array, which is the data, and then the quartile. So we're going to select our data, and then we're going to press comma, and we want the quartile. So again, it gives us another drop down indicating we use 1 if we want the first quartile, 2 if we want the median, 3 if we want the third quartile. So we want that first quartile. Press enter. And we see right away, if you have your list of the quartiles that we did by hand, this is slightly different than what we did by hand. For Q2, quartile.exe, comma 2, 54.5. Now this is the same. And I do want to show you that this second quartile is the same as the median. So we've used that function in Excel, so we could try it and test to see if it's the same. If we did the function median and selected our data, we should get the same exact value. Yep. For the third quartile, select your data, comma 3, 57.75. And then our maximum, again, Excel is pretty intuitive for the most part with these function names. So if you just start typing max, you might come up with what you're looking for. And it tells us that this function max gives us the highest data value in a set. That max is 69. So here I have summarized that 5-number summary when we did it by hand and using Excel. Just a quick observation, the differences between Q1 and Q3, whether we did this by hand or using Excel. Again, the reason for that is the way that that function is treating data in Excel. So if the directions in a problem do indicate to find your 5-number summary or your quartiles by hand, please make sure that you use those techniques of sorting your data and finding those medians by hand. Otherwise, you could use either. So the next thing we want to do in finishing off constructing this box and whisker plot is to determine if there's any outliers. So just for the purpose of being consistent, we're going to go ahead and use those by hand values here, but we could use the Excel values the same way. So first, let's calculate our IQR. The IQR, remember, is Q3 minus Q1. So that's going to be 57.5 minus 50.5, which is 7. And then we need 1.5 times that IQR. So 1.5 times 7 is 10.5. And we're going to use this 1.5 times the IQR to determine that lower fence and upper fence. Our lower fence is Q1 minus 1.5 times the IQR. Q1 being 50.5. 1.5 times the IQR is that 10.5 value we just calculated. So our lower fence is 40. Our upper fence is found by taking Q3 plus 1.5 times the IQR. Our upper fence is 57.5 plus 1.5 times the IQR, or 10.5. $57.5 plus 10.5 gives us 68. Now, using these two, our minimum data value was 42, which is still greater than 40. So we don't have any outliers on the low end, but our maximum data value is 69, which is greater than our upper fence of 68. Now, we might want to look at our data one more time just to make sure that we don't have any additional outliers. So if you have your data sorted in Excel, you can clearly see that the value of 69, that one data point, is the only outlier. So now we'll use this and the provided number line to construct our box and whisker plot. So beginning with the box, Q1 is 50.5, and it looks like these are going by 1, so I'm gonna have to approximate here. But 50.5 is about there. Q3 is 57.5. So now we have the outline of our box, and Q2 is 54.5, which is about there. The left whisker, or our lower whisker, is going to extend to that minimum because our lower fence was 40 and we didn't have any outliers on the left side of this box and whisker plot. So again, our left whisker will just extend to 42, or that minimum value. Now on the right side, on that upper end, we do have an outlier at 69. So we wanted to note that here with an asterisk or a circle. I've seen just a point as well. And then we need to construct our right whisker so that it goes to the highest data point that's still less than our upper fence. So again, we might have to go back to our data set and have it in order. If our upper fence is 68, what data value is less than 68, or the largest data value less than 68? And that would be 67. So again, this is the largest data point that's less than the upper fence. And just to summarize, we're going to compare our box and whisker plot and the quartiles from a histogram, or with a histogram. So when we were talking about the shape of our distribution and percentages, we were starting to build this idea that the area under the curve represents the percent of data values that we have. So in this histogram up here, 25% of our data lies below Q1. And that's illustrated on just this one whisker, this lower whisker. Q2, or the 25% of the values lie between Q1 and Q2, which is right here, which is in this left side of our box. Between Q2 and Q3, we have 25% of our data. And then between Q3 and our maximum, we have another 25% of our data. So this can be somewhat of a tough idea to grasp because it looks like this side of the box is less than this side of the box, but it represents the same percent of data values. So in this entire box, between this value right here and this value right here, we have exactly 50% of our data. A really common mistake is to look at this box and whisker plot and say, oh, the majority of our data lies between this Q1 and Q3. And by definition, majority would be more than 50%, and it's exactly 50%. But how spread out it is can help us identify the shape. So because we have 50% of our data between these two values and another 50% of our data between those two values, we have more data on the lower end and less data on the upper end, making this about a skewed right distribution. And we can see that more clearly with this histogram, right? We can see that this tail here is on the right-hand side.